In this tutorial, you'll learn about the Mecanim animation system and create a scene that looks like this, with a barrel jumping robot that can also jump from ledges and naturally shoot lasers at a spherical object in the sky. To see the finished scene, open the Finished Scenes folder and open the scene file called Tutorial Done. To start the tutorial, open the Tutorial folder at the bottom and load the scene called Tutorial Start. Let's take a look at the robot character we're going to animate. First off, he contains no animation attached to him whatsoever. We can leave import animation completely unchecked. However, we do want to make him a rig that can receive animation. Within the rig section of the import settings for this robot, I'm going to choose the type of character. So this particular character is a humanoid, i.e. some kind of biped type character. And the avatar definition is basically an asset that will get created within the FBX hierarchy. And this is an asset that stores all of the bone mapping and muscle definition. So I can say create from this model and hit apply. And when I go to configure, I can assign all of the bones of the character to the mapping of the avatar. So I can do this automatically by going to mapping at the bottom and choosing auto map. This then applies the bones from the hierarchy based on the order in the hierarchy and also the naming of the bones. So if you're working on a character that needs to go into this system, make sure that you have a standardized character set up that looks something like this, or refer to the other materials that we've put on the asset store for information on how you should put your characters together. Now you'll notice that some of the bones here are in red, and that's because Mecanim would like your character to be in a T-pose. We can fix this simply by going to the pose drop down at the bottom and selecting Enforce T-pose. Now that's completely set up. My character is ready to go. But one other thing that's worth mentioning in this area is that we can go to muscles. I'm just going to apply those settings. And we can apply constraints to different parts of the body if we want to. So we've got muscle group previews, we've got per muscle settings and additional settings. And when we're happy with these settings, we can hit apply and then choose done to go back to our scene. So let's get started constructing our character. First of all, drag and drop the FBX file into the scene. I'm going to place him at the foot of the first ramp. Then, because this scene is set up with light probes, which will enable dynamic light to be projected onto the character, we need to drill down into our robot and set the actual mesh renderer to use these light probes. So expand the parent object called robot, select robot 2 and check the box for use light probes in the skinned mesh renderer component. You should now see that the robot is nicely lit. We can now collapse the parent object. Now we're going to apply all of these animation files and you can see that they're just constructed with some very basic geometry to show how they actually work. So if you have animation files from various sources and they have a vague mesh applied to them, you'll be able to preview them in Unity 4 now. With my walk forward, for example, I can go to Animations tab and I can see the clip that we've made for that. So Unity 4 contains a complete solution for bringing in your animation files, selecting part of the timeline of that animation and creating loopable clips that you can retarget to any character that you want. What I'm going to do with that is start to build up a controller for this character. So when I select my character, I can see that there's a new type of component, the animator. And what this means is that it's a complete state machine that we're going to use to control this character. So if you go to Window and Animator, you can open up the animator. Currently we're looking at the animator for the finished game that we were working on before. But we want to start from scratch and learn how to do this. So select the tutorial folder and go to Create, Animator Controller. And we'll call this My Bot Control. As a brand new animator, you can see here that we're looking at this new one, Tutorial/My Bot Controller. And you can see that the animator window has changed to show us details of this new state machine. It's currently got no states within it, and it's got no parameters either, and we just have a single base layer of animation to get started with. So how do we use this? Well, Let's begin by docking it down here so we can still see our character. So what we need to do first off is apply this to our animator component. So I'm going to drag and drop that as the asset to use. Then, because this animator is going to drive our character around by using the root motion from the animation, we'll make sure that that box is checked. We're also going to make this a rigid body character so that he can react with physics. So we're going to check animate physics also. So now that this asset is applied to our character, we can start to apply animation to the controller and have it affect our character. So let's return to our animations folder. And we'll find the idols FBX file. So in this FBX file, you'll see a single clip called idle. And if I hit preview, you can see it's just a clip of the guy kind of standing still, which is set to loop. To put this into our animator controller, I'm just going to expand the hierarchy of that FBX, locate the clip at the bottom, which has a play button icon, and drop it into our animator controller. You can move around the animator controller by holding down Alt and dragging. Note that it turns orange because this is the default clip to play for this animator. So if I now press play, you can see that my character has that animation. So whilst you can drag in individual clips like idle for example, what we can also do is to bring in several clips into something called a blend tree. We can right click and go create state from new blend tree. I'm going to name this blend tree walk back. I'll double click on it to go into it, and you can see now I'm in a slightly different view, but I have a breadcrumb trail to get back at the top of the animator window. So what I do with the blend tree is to bring in a number of different animations and set up the blend tree to blend them together as different inputs are being used. So for example, in this blend tree, I'm going to have 3 motions, one to walk back in a straight line and 2 more to walk left and to the right whilst walking backward. So let's create 3 motion fields. Click on the plus icon and choose add motion field 3 times. Now we have 3 slots into which animation can be placed. We've created a walk back clip for you. So if you select the walk back FBX and select the clip, you'll see a walking back animation. And we can drag and drop that into our blend tree. So reselect the blend tree, drill down into walk back, and drag and drop the walk back clip into the middle of the 3 slots. Then go to walk back and turn, and drag the walk back turn left into the first slot and walk back turn right into the 3rd slot. So we now have a blend tree that's going to take these 3 animations and blend them together based on a particular parameter. So a parameter in the animator is something that can receive information and apply it to the animator. So in this instance, we're going to be receiving information from input. So I'm going to create a parameter that we're going to use for speed and another for direction. So click on the plus icon next to parameters and choose float and name it speed. Then make a second float and name it direction. The capitalization of these parameters is important because we're referring to it in the script. So this blend tree automatically has chosen the first parameter I've put into the system. But I want this to be based on direction because it's going to choose whether we're walking in a straight line backward or turning left or turning right. So I'm going to change that to direction at the top. Then, because this is based on input, if you've used Unity before, you'll know that the input system is based on a value from -1 to +1. So the lower threshold, this number here, should be set to a value of -1. The Automate Thresholds checkbox will mean that Unity is setting up threshold values for all of your motion clips based on that information. So in this instance, it's set the lower thresholds to -1, the center to 0, which is our kind of idle state for input, and the positive state to a value of 1. So now I'm going to go back to my base layer and I'm going to create a transition from idle into walk back. So this means right clicking on a state and choosing make transition. I then get this arrow that's attached to my cursor. I click on the state I want to go to, and I can then click on the transition I've just made to set up conditions for it. So we need a condition, much like an if statement, to say what needs to happen in order for us to go from one state to another. So I'm going to say that my speed value should be less than minus 0.1. So when I start to press the walk back key or my down arrow, for example, then I'm going to transition into this. I'm then going to right click on my walk back, make transition, and click back on idle. This time, selecting the returning transition to idle, I'm going to say that if my speed is greater than minus 0.1, then we'll transition back. So in order for us to get into this walk back state, we're going to use the speed value, and then once we're in that state, we're using direction to control how it looks. And I can preview that blend tree by pressing the play button on the preview window and by dragging the direction slider to see how it behaves. It should be noted that you can also drag in any character with an avatar into the preview window in order to use that as your previewing character. So for example, I can go into my tutorial folder and drag and drop my robot in and use him as my preview. So now my character is set up to walk back, but we need to actually give the parameters in our animator a value, and we do this using scripting. Let's return to selecting our robot in the hierarchy, and we're going to drag on a script that we've already written for you. Select the scripts folder in the project panel and drag over bot control script. The bot control script also requires rigid body and capsule collider, so you'll see that those components have been added at the same time. Let's double click on the icon for the script to launch it and have a look at how it's providing those parameters some values. You'll see that all the scripts in this project have been commented, so you can read through at your leisure to see how the script works. We're going to be pointing out various things throughout the tutorial to show you how they relate to what we're doing. In this particular instance, we want to look at how those values are set. You can see that on line 48, we have float values set up for horizontal and vertical. So they're grabbing the axis controls for input. We then use set float to send particular parameters a value. So we're sending speed the value of my vertical axis and direction the value of the horizontal axis. Anim simply refers to my animator, which I've set up in a private variable up at the top and then initialized using start and get component. Switch back to Unity now. Let's set up the values for our rigid body and capsule collider in order to make it suitable for the character. First off, set the mass of the rigid body to 60. Then open his constraints and check the boxes for freeze rotation X, Y and Z. This means that the animator is in control of the rigid body's rotation, and we needn't allow the physics engine to intervene as it's being controlled directly by this. For the capsule collider, set the Y center value to a value of 1, moving it up. Then set the height to a value of 2 and a radius of 0.3. Now that this script is applied and we have our components set up for the character, we're going to press play and see our character using the walk back state. So also bear in mind that the animator window will preview as the game is playing, but given that Unity will switch to the game view, you need to have the animator docked somewhere away from the game view so that you can see both at the same time. I'm going to move back to my base layer and then play the game, and I'm going to walk backward and turn in different directions. So I can see if I go into my blend tree and continue to play the game, you can see that it's blending through those different values based on the input values that I'm using with the keyboard sent to the animator via the script. Now let's make some more detailed animation by using nested blend trees to create walk and run animations for the character. Return to the animator panel and go back to the base layer. Right click and choose Create State from New Blend Tree. We'll name this state Locomotion. Enter the blend tree by double clicking on it and you'll see the same empty blend tree that we had before. This time, in the motion list, click the plus button, but instead of add motion field, choose new blend tree. Do this twice. So we now have two new blend trees coming off of the original blend tree. One of these is going to be for walking animations and the other is going to be for run. Select the uppermost blend tree and create 3 motion fields by clicking on the plus icon 3 times. Again, we've created assets for you for this, so simply select the animations folder in the project panel and expand the walk forward animation clip. Scroll to the bottom and drag and drop the walk forward clip into the second of the 3 motion fields. Then collapse this and open up walk forward and turns. Scroll to the bottom to find the animation clips and drag walk forward turn left to the first slot and walk forward turn right to the third slot. If you're losing sight of your blend tree, simply drag with Alt within the animator window to get back to where you need to be. Select the blend tree again if you've lost it, and remember that because we're receiving input with this, yet again the lower threshold needs to be set to a value of -1. And naturally this blend tree is also based on direction, so ensure that that's the parameter selected at the top of this blend tree. That's our walking setup, but we also want to set up runs, so select the lower blend tree, open up runs, and then create 3 slots for motion by clicking add motion field as we did before. Now let's take a look at how these clips are actually created. If you select the parent of runs and select any of the clips and press play, you'll see that we've created looping clips for you. Let's take a look at how we actually put one of these clips together. If you select the run clip and press the minus button, that will remove the clip from this file. We'll then recreate it so that you can learn how you actually do this with a piece of animation data. So the first thing to do is click on the plus button to create a new clip. Now this FBX file has several animation takes, some of him running to the left, some running to the right, and some running forward. First off, set the source take to the run forward, which is called run. This will automatically rename your animation clip based on that source take, so we can leave this as run. Now we have a complete set of animation data of the guy running. You can see it kind of jerks around, so it's not set up to loop properly. So what we can do is drag these in and out points like an editing package in order to set the start and end points for our character's animation loop. So what I'm going to do is find a good point where my character's thighs are together and his right foot is on the ground. Then I'm going to do the same with the end clip, because that will mean that it's matched up. So I'm going to drag back to the start to remind myself of what it looks like. And then I'm going to scroll forward until the right foot is on the ground and the thighs are aligned yet again. And you can see that Unity helps you by showing you green traffic lights when these are matched up, and a graph to show you what those particular parts are doing throughout the animation. And when I release the mouse, I can see that that's set up. So what do the other settings do? Well, first of all, I do want to loop the pose. So I'm going to check the loop box, and that ensures that I get a nicely looped clip. I want the root transform rotation to be baked into the pose of the character, i.e. baked into the animation that he's doing. And then I want the root transformation Y value to be baked into the pose as well. And finally, I'm going to leave the root transform position alone. So basically what I want to do with this run clip is to allow him to move forward in a consistent line. And if I press play, I can see that I'm not exactly getting a constant forward animation from this guy. He's kind of drifting over to one side. So the way that I can fix that is by checking that my average velocity only has a value for Z. I don't want to see anything but 0 in X and Y. So I can use my root transform rotation offset in order to fix this. I can simply drag over this watching my average velocity until it nears 0. Now that we've created my looping clip, I can hit apply at the bottom. I can hit preview again to double check it, and I can see that my guy is running perfectly in that straight line, and I can return to my blend tree to fill it in. So I'm going to reselect the lower blend tree, and I'm going to scroll to the bottom of my runs and then drag run into the center, run left into the first slot, and run right into the third slot. As usual, the lower threshold should be a value of -1, and the parameter for this to use should be direction. Your finished blend tree should look something like this, and you can name the blend trees in order to help you differentiate between them. So this is walks, and this is runs. And now if I preview, I can see my runs changing and changing direction. I can also preview the parent, changing direction and changing speed to go from a walk into a run. And this shows me how it's going to behave before I've even applied scripting to it. So now I can go back to my base layer using the breadcrumb trail at the top. And I need to create transitions from idle into locomotion. So as with before, right click on the transition you're starting from and choose make transition. Select the one you want to go to and then choose the transition to edit it. Yet again, I'm going to use speed. So in the condition, set the parameter to speed, and we're going to say greater than 0.1. So that pretty much guarantees that the user has started pushing the forward axis, be it on the keyboard or with the joystick. Then right click on the locomotion,